Hello, this is the solution to the first practice SAC for the upcoming Year 12 Chem SAC. This is the first time I'm doing this for Year 12, so you guys can let me know later whether this is something that you think is useful. Me explaining and going through the questions as I'm making the solution, or whether it's not necessary. So we'll see how it goes, and I'm still experimenting with these resources, also with the Year 11. So, it's a learning curve for me as well. So I am going to start with the multiple choice questions. Now, ideally, if you have attempted, well, we're attempting this tomorrow. So I'm doing it on Tuesday night right now. And you can watch these videos if you want a little bit more clarification of how to do the questions, so I will upload this with the solution. We are going to start with the multiple choice questions. I see how many I can go through in one video. I probably do 5 per video or something like that, and I may need to insert some more space just in case. Okay, yeah, I think we're gonna do that for everything. And now I do believe that it's going to do this really odd thing when it just jumped to the start of the page. Let's see. Oh, it doesn't do it when you want it to. Okay, let's start with question 1. The electrolysis of 1.0 molar of sodium iodide, AQ, using inert electrodes would produce. So this is a classic electrolysis question. You are given the solution. You know that the electrodes are inert, so they are not going to interfere with your reaction at all. And you need to predict what is going to be produced. So if you need to predict the product, I apologize for my handwriting. It's very hard to write on the part. So we need to predict the products of electrolysis. You want to make sure, and I know people tend to skip steps, like always, but especially in an assessment, this is the time to actually slow down a little bit, and I think it's going to pay off in the long run, especially for multiple choice questions, because you don't know, nobody will ever know how close you are to the final answer. It's either correct or not. So the first step that I always recommend is to list all the species present. So because sodium iodide is in aqueous form, I can split that into Na plus, AQ, I minus AQ, and the last thing that I have is H2O. All right. So now we're going to highlight the species on the electrochemical series. So it goes without saying that you need to have an electrochemical series ready for pretty much every question, almost every question of electrolysis. Okay, so I'm going to highlight every species available. Well, can I even do that? All right, I think I can do it with this one. So we have water. Okay, oh, that works out well. And we have I minus, if I can find it. All right, we have I minus, and on the other side, all right, all right, hopefully you can see, we have sodium and we have water again. So step 2, highlight all species present. I think what I'm going to do is I'm going to take a snapshot of this just to make it easier for you to see on the paper. All right, so if you highlight everything present, and we're just going to quickly insert that here. All right, that's too big. Can we make do? Is that on the same page? Oh, this is annoying, isn't it? All right. How small can I make it? This is just great. No? Oh, well, that's not going to work. All right. Finally, that's technology to you. Okay. So once you have highlighted everything present, you definitely should not spend that much time doing this question. But anyhow, you can tell that on the reductions, the reducing agents, iodide is the strongest reducing agent. So I minus is the strongest reducing agent. Which means that the reaction at the anode is going to be I minus, well, 2I minus going to I2 plus 2 electrons. So iodine will be produced at the anode, which actually, if you look at, because this is a multiple choice, you can cross out C and D immediately right now. And at the cathode, H2O is the strongest oxidizing agent. So you will have, this is so exciting, watching me writing these words. Okay, you will have 2H2O. Now, you definitely do not need to write the half equation out because this is, once again, a multiple choice. All you really need to do is just look at this and get the answer. That's wrong, by the way. H2 and 2OH minus. So the product at the cathode will include H2 gas and hydroxide ions, which is not in the answer, but the correct answer would be B. That's a lot of work for one multiple choice. You definitely could have just done all of that in your head and just highlight on your periodic on your electrochemical series. Moving on to question 2. Oh, all right. I like question 2. Question 2 is difficult though. Let's not actually pretend that it's not difficult. This is going to be a difficult question. To be fair, it is difficult, but you can logic your way into it, depending on how good you are. And we'll see whether you surprise me. Okay. Electrolysis is conducted on molten solution of lithium, sodium, and a third metal. I think I'm going to increase the size a little bit so that my handwriting doesn't look outrageously big compared to the text. Yeah, it's conducted on molten solution of lithium, sodium, and a third metal. The graph below shows the mass. Now, this is important, the fact that it is a mass. The mass in grams of each metal formed the negative electrode. Now, the negative electrode is your cathode. So this is electroplating, basically, as the amount of charge increases, and you need to determine the third metal. So this is your third metal here that you need to work out. All right. So you have different options, and I think we have Ag, which is plus. So if I write the half equation for Ag, it looks like this. And then for magnesium, plus 2 electrons going to magnesium. Potassium is also a one-to-one relationship between the number of mole of electron and the metal. And for calcium is 2 plus 2 electrons going to Ca. So you can get these half equations definitely from the electrochemical series. I'm just going to remove the highlights. Make sure that you check those because you need to get the correct mole ratio. Okay, so because this is in mass, now what you can see here, and this is what I tend to do, is I tend to see I want to know the amount of metal that is produced using 1 mole of electrons. Now, there is no scale here, and there is a reason why there is no scale on the vertical axis, because you have to use the other two graphs in order to work that out. But it kind of well, the mass is not going to tell you a lot of things. You really need to convert it to mole. But I'm gonna try that. So if the number of mole of electron is 1 mole, if we think about lithium, the half equation for production of lithium metal is you have lithium plus electrons going to lithium. So if I have 1 mole of electrons, that will produce 1 mole of lithium, which has a mass of, I think, around 7, if I'm not mistaken. Yep, 6.9. So 1 mole of electron produces 1 mole of lithium, or 6.9 grams. So that presumably is around 7 or 6.9. Now, sodium has a similar ratio between the number of mole of metals and the electron. So once again, if you have a mole of electron, you get a mole of sodium. And a mole of sodium has a mass of about 23 grams. So that around here would be 23 grams. Now, this looked to me like it's approximately double, so maybe around 40-ish, a little bit less than double. So basically, you need to determine the metal that's going to produce approximately 40 grams of mass when 1 mole of electrons is used. If we go through, I mean, you can tell, you hopefully can tell what the answer is, but I'm going to go through all of them anyway. If I have 1 mole of electron, I will produce 1 mole of silver. So the number of mole of metal is also 1, because of a 1-to-1 ratio, and that's equivalent to 107.9 grams. So this is just converting the number of mole of silver into its mass using the molar mass. So definitely not A. Now magnesium, if you get 1 mole of electron, the number of mole of Mg in this case is going to be 0.5. That doesn't help because that will only produce around 12.15 grams. Okay, so it's not B. Moving on to C. It's once again a 1-to-1 ratio, so the number of mole of potassium is going to be 1. And that equates to around 39.1 grams. So that's very good. That's almost 40. But I'm just going to go through D anyway. Now the number of mole of calcium is going to be 0.5 mole if I have 1 mole of electron, and that means only around 20 grams in mass. So the final answer should be C, potassium. You definitely need to think about the fact that this is the mass they're plotting, not the number of mole. And you really can only see a ratio if you do some sort of mass to mole conversion or mole to mass conversion in this case. All right, that's question 2. Moving on to question 3. Which one of the following statement is true regarding both galvanic cells and electrolytic cells? All right, let's hope. Well, this one I think it's actually on one of the silent quizzes, but I decided to keep it in anyway because it's always good to be reminded of the basic theories, such as what is the difference between galvanic, or in this case, the similarities between galvanic cells and electrolytic cells. Now, the anode is positive. That's definitely wrong. The anode is positive only in electrolytic cells, and it is negative in galvanic cells. Electrons flow from the positive to the negative electrode in both cells. This is not true either. Electrons always flow from the anode to the cathode, but since the polarities of these electrodes change between the two types of cell, you cannot say that the same polarities hold. So that's B is wrong. Reduction occurs at the cathode. That's correct. The definition of a cathode is side reduction. And D is definitely wrong because you don't need a salt bridge for electrolytic cells. And once again, we have another C, part C. Okay. Oh, that's fine. I mean, I didn't really stage these questions so that you have a pattern or anything. So if it happens, it's randomly. It's by chance. It's not. I don't have a hidden agenda for that. All right. Question 4. An electric current was passed through an acidic solution of copper 2 sulfate. So that's your electrolyte. 32 grams of oxygen gas was released at 1 electrode. Now, this is another question that was in the silent quiz, but I still want to keep them in here, mainly because not everyone has done the silent quiz, and also because a lot of people got this wrong the first time, and I really wanted to see whether you guys have actually looked at the solutions and correct your mistake, or whether you recognize it when you see it again. So you have 32 grams, which means that I can go back to your silent quizzes and check and see whether you get this question correct now, if you got it wrong the first time. So 32 grams of oxygen gas was released at 1 electrode, and then all of a sudden they asked for the mass of copper deposited at the other electrode. Okay, you definitely need the number of mole here, because the only way to connect the two electrodes in a galvanic cells is to think about the fact that they have the same number of moles of electrons flowing through them. So I'm going to work out the half equation. This is copper sulfate AQ. So we have Cu2 plus SO4 2 minus, which will be treated as a spectator ion, and H2O. So the anode reaction is going to be O2 plus something. I actually don't remember. That's actually wrong. I don't know why I have O2 there. All right, my bad. H2O going to O2. What else do you need? I think you need OH, H plus. Really, you should check the electrochemical series. Yeah, O2 plus 4 H plus and 4 electrons, and that gives you 2 H2O. Okay, so that's the anode reaction. You have 32 grams of oxygen gas. Now, gas is an important thing here, which means O2 and not O, and that would change the number of mole if you don't remember this fact. 32 grams of oxygen is the same as oxygen gas is the same as the number of mole of 1. Now, if the number of mole of O2 is 1, then the number of mole of electrons is a quarter, or ha ha ha, not a quarter, 4 times 4 electron mole. What is going on? I haven't had dinner. I'm kind of hungry. All right, that's going to be my excuse for making random mistakes in this. So number of mole of electrons in this case is 4, and the same number of mole is going to be used at the cathode, which is when you actually produce copper 2 plus into copper. So I have 4 mole of electrons still, and that will produce 2 mole of copper. And the last thing to do is to convert that to mass, which I think is about 127, but you know, because I am paranoid. I mean, it's the only logical answer if you look at the options, but I just did it in the calculator just in case. So final answer is D. Now, a lot of these working out can be done just by staring for a very long time at the electrochemical series and make sure you look at the mole ratio. But this is just to show you the full working out. All right, I think we have time for 5. Now you look at this and you just, you know, it takes your breath away, the amount of information provided. Have no fear is probably the first thing I would say, and embrace the challenge. It's electrolysis. It's supposed to be challenging, but you'll feel very good once you solve it. Now I'm gonna confess I haven't read this question, so let's hope that I can do it. So we start with vanadium redox battery, and it's a rechargeable battery, exploits something. I feel like I already put this question in a salad quiz as well, but I can't remember. Maybe it is. Could have checked. Never mind. Ability of vanadium to exist in solutions in 4 different oxidation states. The species which can exist in solution appear in the standard half cell potential. So this is a type of question now. I'm gonna guess it's the type of question when you're given a mini electrochemical series that you can use and apply on top of your regular electrochemical series. So we have different species of vanadium here. The cells in this battery have different electrolytes around the positive and negative electrodes. Okay. When the battery is delivering an energy or being recharged, the electrolyte at one electrode contains species with +5 and +4 oxidation numbers, and the electrolyte at the other electrode contains species with +3 and +2 oxidation numbers. The Hab equation for the reaction occurring at the positive electrode when recharging. Okay, positive electrode of recharge is your anode. So we're looking at oxidation here. Oxidation is a loss of electrons, so immediately I can cross out B and C, which actually depict reduction. Okay, I have no idea what's going on, so what I'm going to do is I have to potentially work out the oxidation number so I can tell which one's going to be involved. Okay, vanadium oxidation number. So the oxidation number oxygen here is -2, which makes that +5. And we have -2 and whoa, that's wrong, +4. Okay, so this one does go from +5 to +4. And, okay, I think I can kind of see -2, +4, and then +3, and this one go from +3 to +2. So if that is the case, then your reduction during discharge is going to be the first reaction. Okay, I don't know why it does that, and it's just did it again. So this is reduction of discharge, and this is oxidation of discharge, because it's already arranged in the correct order, so the higher one is going to undergo reduction spontaneously. Now I am looking for the anode of recharge, which is going to be the reverse of reduction. Let's just write discharge here for those who are not watching the video and just going to look at the solution. Okay, the reverse of discharge, reduction. So it is going to be the reverse of discharge reaction. So what we are looking for is actually the reverse of this equation. The reduction. Okay, actually, I think I'm going to change this a little bit just so that it's a little bit easier to see. Okay, so the oxidation of discharge is going to go in this direction. The reduction of discharge is going the forward direction. So if we are looking for the reverse of discharge reduction, we're looking for VO2 plus H2O going back to VO3 minus. The answer is A. Not too bad, I think. Not too bad. So that's the first 5 questions. I'm going to pause now before I start this up.